Okay, so we are now moving on to the last technical session for the day, which is data visualization through R. It's a lecture plus hands-on session, and the session will be taken up by Dr. Tridip Ghosh. He's working as an associate. He's associated as a research scholar at Indian Agriculture Research Institute. Dr. Ghosh holds a PhD with specialization in agriculture physics, and his area of expertise include data analytics, remote sensing, and GIS. Dr. Ghosh, you have a total of 55 minutes in your hand. I will be giving you a heads up by 6:15. You need to wind up the entire session by 6:30, including questions. Over to you, Dr. Ghosh.
Yeah. Thank you. My slides is visible. My slides.
It is visible to me. Is it visible to all the participants? Okay.
Okay.
Fine.
Thank
Please go
you.
on.
This session we will learn about some data visualization through R. This is the topic to be covered, as already Dr. Das has covered the directory setting and reading the file. I will be skip or in brief I will discuss. Then little bit about the data manipulation, different types of data, how to handle it. Then data visualization, different bar chart, scatter plot diagram, blocks plot, how to analyze and how to beautification of that particular figures. Then spatial data visualization, that means raster and vector data visualization. Okay, so as I already Dr. Das has told about the how to set the directory, that is set working directory. This is a function and we have to put in, and for the to set the directory, and whatever the all the output will be saved in that particular directory. So I hope all you have got that code that I have shared in the resource group. Just go with us. Now this is the setting the directory. Directory means whatever the you see the whatever the files are there, then we have to copy it, the path. Just a second. Yes. So this is my working directory. I just copy it, and then I have to paste it here. Here is my setting the working directory. All the files will be generated and also read from that particular directory. Then I have already told, that is we have to give the double slash or otherwise forward slash in single one. So this is the working directory has been set. Now by default, R can read the CSV file by using this function, that is a read CSV, and we can store in the another variable name, that is HSV. But I have shared with you there is an Excel file, so that's why it needs an external libraries called OpenXLS. So similar fashion, that is install.packages and inverted comma, we have to write the package name, that is OpenXLS. Then we have to call that particular library. As I have already installed it, you may please follow that particular line. Thereafter, we have to load the library in our R system. Okay, fine. So now next step is to read the particular data set. So what is the data set I have? This is the data set, that is ID, gender, then socioeconomic status, and how many person read, write, mathematics marks, science marks, and social science marks. These are the some data set and temporary data set or arbitrary data set that I have provided with you. Then just read it. Now I have to bot in the R environment, and I have to read that. So that's why we have to use that function, that is a read.xls. This is the function, and this is all the arguments. In arguments, we have to first of all provide the name of the dataset. Name of the dataset, I have created the data, that is a dataset name, and with extension we have to provide, that is .xls. And also we have to mention the seat name. As I have already one dataset seat name, you may escape this step also. And if you have the multiple dataset, you can mention the seat equals to that seat name within the inverted comma. Okay, fine. So now just load it whatever the result output will be generated, and I store in the data variable name, that is HSP. Okay, So c is a variable name. There is all the data set. You can just double click it and run it. You can see there is all the data set in the R environment now. Okay. Now see the structure of the dataset. str, this is a function. You can structure the dataset. There is all the numeric values. It is by default it are taking as a numerical values. So this is the all the numeric. Whatever the variable name we can see. By the names function will give you the column names. Just see there is a ID, gender, socioeconomic status. These are all the column names we can see by using the name function. So now we can also check the head function. Head will give you some top rows, but mentioning how many rows you want to see. There is a 3 I have mentioned. You can also check the tail. There is a last bottom rows. By I have mentioned there is a last 4 bottom rows. You can also check that particular values, whatever the rows are present. Now, in brief, there is a statistical measures we can go ahead, check. There is a calculate the mean value, whatever the variance, what is the standard deviation. So just for that, we can just write mean. Mean is a function. Automatically it come. Then whatever the data set you have, there is a HSV data set, and just put the dollar sign, and automatically it will shows which one it want to looking for. I suppose I am looking at the science. So just see there is a mean value. All the observations, the mean value it is has been calculated, the 51.85. So similar fashions, we can say the variance, how many variance will be there, how much, then the standard deviation is calculated, and then you can put the store in another variable name. Another variable name, that is the I have put it is a m variable name. You can store it m, then just double click it and run it, and it will get the same output. So this is the first some basic statistical analysis. Now also you can check the summary of the dataset. Summary, that means it will go get the minimum value, then first quartile, then median, mean, then third quartile, and maximum values for all the columns that you have in that particular dataset. So this is for the summary. Okay, this is the basic things. Now you can manipulate the dataset. Some changes you want to make over the dataset, and select some specific rows, specific values of a particular column. For that, some basic data manipulation we may need. That's why we have used some external package. It's called the dplyr. Some basic functions I have listed here, that is more is important. We have to learn that. So that's why some basic, there's a plenty of functions are available in this particular library, but we have just interested in some basics and most important ones. Okay, fine. Now just see there is a similar fashion, you have to install it. There is a install.packages dplyr. This is the package name. Then similar fashion, you have to load it. You may follow the first line. I already have this, but that's why I'm skipping this install.packages line. Then I have to load it, because whenever you want to see work with that particular session, we have to load it, the library. Okay. Now here we have going to see there is a one operator. It's called as a pipe operator. Okay. The pipe operator, what does it mean? There is a in a plumber, you can say there is a connection between the pipe. So there is a we can concatenate the number of the pipes, or we can attach and subsequent section. So to get some multiple functions. So this is the pipe operator, and this is the shortcut of this pipe operator, that is the control shift and m. Now what is it is doing? Now I am interested in the to see the whatever the distinct genders are there in that particular data set. Distinct function will give the unique values, number of unique values that are we have having that particular column. So these automatically take the HSV dataset and piping it and calling the distinct function, and within the bracket I am giving the argument, that is the gender. I am interested in gender. So just run it. It will give the 0 and 1. Okay, fine. So there is only the two values are there, 0 and 1. Now you can interested in the socioeconomic status. There is whatever the distinct there is a values are there. There is a only three values are there, 1, 2, and 3. Fine. Now you can also arrange the dataset. Like if you original dataset, you can see there is the ID values are in sequence. So you just want to make it more sequence and visually appealing, we can say. So that's why you can use the arrange function. Arrange within the bracket, you have to pass the argument which one you interested in. So I am interested in the ID. So just see there is all the values in present in the ID, they are in ascending order. Just see 1, 2, 3. So they are arranged. Okay. Just I then we can use the filter function. A filter function all we can use in the Excel also, but you can few comments we can deal with the filter function. The filter function you can select some specific value in a particular column. You can also the multiple operations you can done. There is a greater than, then less than. There is a multiple operation. Forget about that. In this particular session, we are just looking for in a particular value that is 1. I am going to select the socioeconomic status of 1 in a filtering that from that particular data set HS. Now, also we can piping it. Then next operation it also comes. That is this is the beauty of this pipe operator. Can select. We can go ahead. There are multiple functions again and again, but subsequently. Okay, now selecting the select function is carrying calling the that is whatever the mathematics and the science marks are there, having the socioeconomic status of 1. So just calling it, just run it. You can see that whatever the socioeconomic status 1 values are there, their science and marks values, science and mathematics values are that is displayed. So you may interested in socioeconomic status of the 2. So just click it and you can run. That is the whatever the data values are there in the socioeconomic status 2, their science and mathematics marks are given. Okay. Now you sometimes you may change the column name. So there is a column name SOST. There is original data set you can see. So there is a column name. There is a SOCST. There is a column name. Now I want to change this name. So I'm putting there is a social. Now we have to follow this syntax. There is a social equals to SOST. That means it is replacing the social SOST values with a social that particular character or we can word. So see, so these values has been replaced. Fine. Now next we can another important function that we have to learn, that is a mutate function. So mutate function basically what it does, it generate another column. So based on your interest. So now what I am doing that is a taking some data from that particular data set. Then I am mutating the gender value. Now I am altering the gender value 0 with male and 1 with a female. So another function it is working is k-showing. K-showing is just matching. It is a searching for the match. Like, okay, gender wherever is there 0, just replace with the male character, and wherever there is a 1, just replace with the female. But I don't want to get just another extra column. What I'm doing, there is a same column, I'm just replacing it. There is a gender. Okay, so just here I am not creating the same value, same column name. So just see there is all the values wherever this 0 is there, that is replaced by the male, and wherever is the male, there is a 1 that is replaced by the female, and also it is putting into the same column name. Fine. A similar fashion with the socio-economic status, I putting the 1 value is the rich, 2nd is the poor, and 3 is the medium. So just check it, the data set head of the data set, and just you can see that is all the values are replaced. Fine. That the mutate function, it is the function of the mutate. So now another mathematical operation you can do, that is a mutate function. Now I am creating another column value, that is a mean marks. So the mean marks, how you can calculate, that is all the values whatever the 3 subject are there, and I divided by the 3. So if you run that particular column, that is a code, you can see there is a 1 extra column has been created. So this is all the mean marks of each and every individual or having the ID whatever. So this is the mean marks has been calculated, and this is the another extra column that I am creating. There is a creating new column, but here I was replacing with the same column name. Whatever the outputs are there, there is a replaced in the particular column. Okay. So next, there is a group by and summarize. There is a most important, the group by, that means grouping that particular that is data set based on some criteria. So I am interested in the group the data set based on the socioeconomic status, that is a rich, either poor or the medium. Fine. Now summarize function, it is basically calculating some statistical measure. So statistics, that is calculating the mean value, then median, then standard deviation, and number of the individual having. So just see there is a mean function, then mean within that first bracket, there is argument I am passing, there is a mean marks. So whatever the mean marks are there, calculate their mean and then put in a variable name m. So just see that based on that, so each and every socioeconomic status having their mean marks, their standard deviation, it is represented by the S, there is a median value, and there is a N, there is a number of the individual are in that particular group. So this is the basic, most important statistical or the data manipulation operator present in dplyr. There is a other plenty of operation you can explore. I have provided that particular PDF function of that PDF, that particular package or libraries. Okay. So now coming to the data visualization. So similar fashion, we have to install another package that is a ggplot2. So you just install it and call the library ggplot2. So this is the most important and most used visualizing package, we can say. So ggplot2, it is the full form is the grammar of graphics. There is a graphic concept that describe plots using the grammar. Like English grammar, we can use the plot. Plotting use is here. Here is used. Then there is a basic syntax is there. There is a ggplot. First of all, we have to there is a ggplot function. Then ggplot function, we have to pass the data set. There is a data equal to whatever the data you are using, or the data set name or the variable name, where the data consists of. Then we have to put the aesthetics. Aesthetics means we have to provide the x-axis, what you are going for x-axis, then y-axis, and the fill. If you are want to change, get the color, there is a number of aesthetics that are there. We will explore that. So just you can give the fill or the color based on your interest. Now then next part is the geometry. Which plot is what you want to looking for? There is a scatter diagram, you have to use the point. There is a bar diagram, then the histogram, there is a bar chart, there is a plenty of chart that can possible. So this is the geom underscore that particular method you have to use. The geom means the geometry. Then there is a facet wrap. Facet wrap function, that is a wrapping the entire that plot into the different section in the vertical direction. Then grid that will generate in the horizontal direction. Then theme. There is a plenty of themes are available. We can use, there is a black and white, minimal. There is a themes. We'll explore them later on. Okay, now back to scatter diagram. So this is the syntax I have already discussed, that we have to call the library ggplot2 first of all. Previously we have to install it. Then the scatter diagram, the ggplot, this is the basic first function. We have to pass the data equal to my data name is hsv. Then aesthetics, we have to pass whatever the x-axis you are looking for. I am looking for x-axis read and y-axis the right. And I want to get the separate dots, or you can say separate points based on the socioeconomic status. Okay, in the geom point, I am looking for the scatter diagram. That's why I have to call the function. There is a geom point underscore point. Then you can control the size of the particular you can dots. Then alpha signifies there is a lightness or brightness, opacity of that particular points. And you can also use the geom smooth. It will give the trend line based on the linear model. Okay, so just let's see. Just click it and it will automatically generate in that particular plot section. Just wait for it. Okay, just see. So this is the trend line. In blue line, it is showing the trend line, and there is a different dots which representing the different socioeconomic status. There is a round one, it is representing medium, the triangle representing the poor, then it is the square one, it is representing the rich. You can also change this if you want to interested in change the size of that. You can increase the size. Automatically the size will be changes. Then instead of the shape, you can use the color function or the fill function. So better to have the color. You can use the color function, though based on rather than it is having different shape, it will generate the different color. Fine. So different color for the different socioeconomic status. Okay, fine. So now many of us were interested in different R square value and also the linear equation. So that's why we can use the library ggmisc. So similar fashion, you have to install it. Then we have to call the library. A specific function we are using is there is a stat polynomial equation, and use that aesthetics as it is. The arguments, that is access level is equal to paste the equation level, then RR, that means whatever the r square value, then there is a separation, and then where in which direction or which position within the plot you are interested to uh, kept it. So this is defined by using these arguments. Then formula is linear equation. There is a y is tilde, there is a relation with x. Then size, you can use this size, adjust, you can adjust the size of that particular line. So you see there is a equation, that is a linear equation has been shown. There is a y is equal to 24 plus 0.552 into x, and r square value of 0.36. So this is not available in the basics arts or the ggplot. You can use this library to generate the r square value. Okay. Now coming to the bar chart, similar fashion ggplot, there is a data has to be passed. There is a y-axis, x-axis, and I am interested in fill the column based on gender. Then geom bar, there is a bar plot. We have to use some statistics. That means we have to put some mean value. I am looking for the mean. And each column, it is representing the mean value of that particular criteria. There is a mean marks. Okay, so you can control the width of that particular bar plot. Just see, just width of the bar plot. If you increase this width, then it will be more spread horizontally. Just see, and you can little bit of thinner, so it will be more visually appealing. Then stat summary, it will generate the error bar, geom error bar. This function you can use to attach the error bar, and their width can be controlled by using similar. Similarly, you can width also can be controlled. Okay, just see it. This is the, but manually we can also, if you have the representative data set, in this case it is not possible, but you can use this geom error bar function yeah, to be based on your own specification of the data set. If you have standard error or the standard deviation and the mean, then you can, or you can, your data set, you can manually can control the error bar based on y mean. You have to put the mean plus standard error, and also y max, you have to use the mean minus standard error. This is the criteria. Okay, position dodge, that means you have to no overlap will be there, so there will be the distinct separation between the two columns. So this is controlled by the position argument. Fine. Now you may interested in the, it is vertically direction, but you may plot it in horizontal direction. In some cases, in some plot you are interested in horizontal, then you have to call this function. There is a coordinate flip. This function will similarly, but rest of the arguments are same, but we have to use this coordinate flip function, and it will adjust in horizontal direction. Fine. So now histogram plot is also possible. Histogram, some you have to use the geom histogram plot. Then you can use the color. Color, it means outside border, and it is field. It is controlled by this field function. You can use different color. You are using the blue, so just use this blue. It will give the preview of this particular color, and you can control it. Border is also can be controlled by any other color you can use. But keep in mind, it is a case sensitive, but you have to use as it is in the lower case. Otherwise, it will not work. Okay. Similarly, you can use the line diagram. So in the line diagram, similar fashions. The rest of the other, all the arguments are the same, but we have to use the geom line function to get the line diagram. I've used, there is an ID in the x-axis and the mean marks and the respective IDs, and how it is varying, you can see. So this is the line diagram, you can say. So then coming to the box plot, you have to use the geom box plot. This is the functions for the single variable. But for multiple variable, you can use, there is a x-axis, I am interested in gender, and y-axis, I have used the rate function. That is how many people are rate, their variance. So before that, you can see there is a how box plot defined. Box plot, there is a entire statistics of the data or the column. You can see there is a maximum value, minimum value, then first quartile, then third quartile, then median, that all are can be described by using the box plot. Okay, so this is the box plot, but this black dot is representing the outliers. So this is the outliers, and you can also attach the mean value for each and every box. For that, you have to use the stat summary function. Stat summary function, within that function equal to mean, And position, you have to calculate the position dot. That means that will be center of that particular box. So based on that, you can attach also the mean value. So it is all the statistics almost it is representing there is a minimum value, then it is a maximum value, then it is representing the median, then dot representing red dot is representing the mean value, and this black is outlier. And I have colored it based on the socioeconomic status. And whereas this is the x-axis, it is the female and the male. Okay, fine. This is the plenty of informations are there in this particular blocks plot. Similar for the violin diagram, you can use the violin plot, and the violin plot, this widest or the thickness, it is representing the frequency of particular values. And similar fashion, the red dot is representing the mean value and how it is varying. I have colored it based on the socioeconomic status, similar to box plot. Then also you can use the density plot, the density of the data set, how it is varying. Here we can use the geom density. This is the function are used for. Color is equal to black, that means outside border, and alpha, it is a thickness or the opacity of that, it is controlled by alpha. And I have filled it based on the socioeconomic status, and I am seeing there is a read, the how many people will read, and the density is represented by the y-axis. So just see there is these highly dense populations or the individuals are there with having the marks minimum little bit of 50, 45, and having the socioeconomic status of the rich. So then green line, it is showing there is a poor, there is a most of the frequency, most of the people are got about the 50 marks, mean marks. So this is it is signifies how the density plot can be interpreted. Okay. Now next come there is a facet wrapping. Facet wrapping, that means we have to group or split it, the plot into the different section in the vertical direction. Just see the facet wrapping. Similarly, I am using the scatter diagram and I am want to split it based on the socioeconomic status. So before that, we have to use the tilde function, tilde, that is the functions, and then or the symbol, then based on what you want to split it. So that column has to be, you have to add. So based on that, there's a split will be happen. So I want interested in scatter diagram. In the x-axis, I have placed a red and the right, and they're splitting it based on their median, poor, or the rich. Fine. So now there is also another function, that is a facet grid. So here I am want to add, there is a grid, there is a horizontal section is also there. So in the vertical section, I have kept it the female and male, and in the horizontal direction, there is a median, poor, or the rich. And this is a scatter plot. In the x-axis direction, there is a red, and the y-axis direction, there is a right. So each and every combinations can be shown by facet grid or facet wrapping functions. Fine. So now these plots are obviously not looking good. So now we have to beautification, that is more improvisation has to be done, so that there is a just to look it more beautiful way or the visually appealing, you can say. So just see, then we have to use then different annotations are there. So so there the annotation, there is x lab. X lab, these functions will give you the whatever the title you are want to give in the x direction, that is I have put it in gender. Then y lab, y lab simply you can put in the quotation, there is a number of person can read, I have put it here. Then gg title, we have can put the gg title that will generate the main plot title, I have given in the blocks plot. Then this is the theme, there is a number of themes are there, I have used the black and white theme. This theme look like whatever the plot has been generated. Then within the theme function, we can use the different argument like strip axis, strips dot text, y, z, then title, then text, then legend text. So these are the different argument, and whatever the symbol you are that we can say there is a font that we are used. There is I am use the serif font here, then their size, then face, then there is a bold or either not bold. So that has been controlled by these arguments. Now we can see there is a what is stands for what, like just see it. uh, this is controlled by, there is a top panel that is in the x direction, that can be controlled by the strip dot text dot x. So this is controlled by these functions. Now in the y-axis, it is controlled by strip dot text.y. This is the panel control strip, that is the controlling the panel. Okay. Now you can use the axis.text.x, that is the x-axis values, that is what is the values are there that has been controlled by this function. Then you can use that similarly axis.text.y, that is a y-axis direction. Then you can control the title of the x-axis, that is the axis.title.x, similarly for y. Okay. You can also use the legend text, that is control the legend title. So these are all the arguments or the functions that I have listed here. Just explore it and you can easily learn about what is stands for what. So just see it. There's a strip axis. This is how beautiful it looks like. Okay. Now you also control the scale of the y-axis, and just see it. I have the range from the 0 to 10, that is a minimum value of the 0 and maximum value of the 10, and I have got the interval of 5. You can change that. Now looking at 2 interval, you just control it. You can control it that see there is a y-axis values are more frequent way. So you can also control the x-axis similar way. Just save it. So there is a two ways we can save the plot. You can just export it based on your convenience. You are either want to save in image format, so just directory that will already have saved or the set in that particular location it will be saved, and otherwise you can choose your own directory. Then you have to give the title, then you have to save it. Okay, it will save it in the form of image, or also you can save it similar way in the form of PDF. Okay, so this is one way to save it. Otherwise you can save by a function that is a gg save. So first of all we have to pass the title with extension, that is you want to save in PDF format or JPG format. This format extension has to be given, followed by the plot equal to last plot. Last plot, that means whatever the recent plot has been generated, that will be saved only. Okay. Then width, then whatever the width you want to do, then height of the particular plot, then units. Units is in what format it is, inch or the centimeter or millimeter, that I have to specify. Then whatever the resolutions you want to save. So if you run that, it automatically got saved in that particular directory which I have saved it. Okay. So these are the different themes that I have listed here. You can explore. There is a minimum theme, minimal, black and white theme, then theme void. So these are the different themes. Just explore it. Okay. Now, based on that, there is another annotation. There is something like you want to give the horizontal line, then vertical line. So these are the syntax. So just run it, then it will be clear to you. So now what I'm doing, I am interested in the split the plot into the two and to check whatever the person getting maximum mathematics value more than 50 and the science value more than 50. So these coordinate is defining. So based on that, we can use the geom h line and intercept. You can control. I am getting 50. Even you may interested in 60. Just put it. Then vertical line similar way you want to get the 60, you just put it the 60, and the color you may control it. You may interested in vertical column blue, you just put it blue, and their thickness is also be then just put a comma. So you may check that. So you may categorize it, how many persons are getting mathematics marks more than 60 and the science marks more than 60. So this many people are there and belong to which category, they are male or the female, that can be also be seen from this particular plot. Okay. Now I'm coming to the another package. This is the Me10 package. So this package is where basically used to Pearson correlation statistics analysis. So this correlation coefficient, this is the function, and you have to pass the data set. So that will be saved in a variable name that I have used, that is a core. Then just click the plot within the in the bracket. We have to pass that variable name. It will automatically generate the Pearson correlation. There is a each and every how they are related. There is a strength of the relationship in terms of the correlation coefficient that are be given, and in the bottom that will be given that is a significance values. Okay. So this all about there is a data visualization. Now coming to the spatial data visualization. Okay, the spatial data, that means there is a two categories of the data. There is a vector data and raster data. Okay, so these real world can be represented by the two ways. There is either vector, either raster. In the vector, you have to have the point, line, or polygon that had been represented by the latitude and the longitude. So, and in the raster, we have to use the pixel values. So, similar rectangular coordinate system, that is similar dimensions will be there, that will be representing the raster data. So basically vector data we are used for the discrete object like the tree, or the river or the line. That means there is a road that can be represented in terms of discrete. And in the raster that are already that are being represented for continuous object like the slope, aspects. So these are represented by continuous data. And these are the formats. And while you are using the vector data or the specifically the shapefile .shp extension, you have to have all these formats. Keep in mind that is all these format have to have in the particular file or the folder to use the shape file. And the raster data, this is the extension that is a .tiff function, .img, .jpeg. These are the format for raster data. Fine. So now back to that R. So to analyze the vector data, we have to have some packages and just install it. There is a library like tmap, .sap, .leaflet, and .r color viewer. So basically the color viewer, this is for the different color setting, and the leaflet also, and the shape file sap that is to read the shape file, that is the vector data, and tmap to handle the spatial data set. Okay, so now I have already shared with you the vector dataset. In the vector data folder, you can check, and there is a shape file name .shp. So there is a function that is coming from sap package. There is a read underscore sap. Fine. So these function we have to use to read that shape file. Shape file, that is vector data, that is in terms of the polygon is there. And whatever the output is generating this function, I have stored in a variable name ind.sep. That is the India sep file. Okay. Now we have to plot it. The plot function, and we have to pass the argument that is the name of that particular variable. That is the India.sep, and just hit the run button, and you can see that is the India sep file has been generated. Just wait for a few minutes, few seconds. Okay. Just see. So this is the India shape file with different colors are there. So this is the only way you can read the shape file, and after that you can plot. So you can check the summary of this data set. There is a what are the length of the number of the columns are there, what are the class, there is a character data set. You can check it, but you also see the data set by using double clicking that. There is a state name, the state name, that is a st dot underscore the name, there is a state name, and their geometry, that is the polygons and having their coordinate are represented here. Fine. Now I have also shared with you a csv file that is representing the fertilizer consumption. Okay, and each and every states. So just check it in a csv format. So this is the function we have to use. There is a read.csv function. Then is you have I have stored it in the fertilizer for the data, fertilizer data. Then you can check the what are the values are there. There is a state name, then urea, DAP, MOP, complex, and SSP. What are the consumption for each and every state? Fine. So now what I am doing, I am attaching this CSV file into the save file. So that's why. So I want to merge it, that the two variables or the two data set into one. So this is the function, there is a merge function with respect to what are the variables I want to choose. There is the India shape and the fertilizer data. Okay. So now X, there is a state name, that is what we have seen, that is a in the India shape there is a one variable name, there is a state name, and there is a in the fertilizer data there is a state name. You see, so there will should be have match. So based on the match we have merged it. So just see India fertilizer. Okay, so just you can check there is a head. Oh, just sorry that you can check the summary of the data set. Just clicking it, you can see. So this is the summary. That means, but you just double click it and run it, and you can see that it already merged. So that means state name is there. Then urea, DAP, MOP are all being attached with that save file. Fine. Okay, now you have to plot it. Now you want to see, you're interested in the whatever the urea consumption in each and every state. So this is a function QTM. QTM, that means quick thematic map. So these functions are used, and I am passing that shape file, that is india.shape, and I am interested in fill the value based on urea. What is the urea consumption? So this is the column name. Okay, so just inverted bracket, we have to pass that urea, that variable name, and it will plot it based on your interest. So just see, this takes time little bit.
Tridib, yeah,
Yeah.
so sorry to interrupt. Like, we have 15 more minutes. Just wanted to give you a heads up uh,
Okay.
to be done with the
Okay.
session as well as have all the Q&A done.
Okay. Just I'm completing. Okay.
Sure.
So this is the plot. So you can see there is a urea, and each and every slab, that is 0 to 100. What are the colors? Each and color is denoting how much urea consumption is there in each and every state. So you can explore. There is a palette that this is a default palette. Palette means there is a shades of the green. There is a number of the palettes are there. I have used the green. Then you can use the shades of the green to fill and each and every polygon. So just see it. Uh, Now I am skipping something. I have to complete it, and okay, these are all available in the particular code. You just explore it. Now, okay, this is see that this is the shades of the green, different greens, and which is representing the urea consumption. So now coming to the end of this, that is how can we plot? There is a two variable. There is a urea. I want to fill that polygon based on urea, and I am want to give a bubble. That is a bubble or the point based on the DAP consumption, and their color is blue. Okay, so this check it. It will come. And in the meantime, I want to say there is a TM border. This function, it is giving the polygon border, and their contrast alpha, it is controlled by this contrast. There is a lightness or the brightness, and the TM layout, it explore. There is a legend outside. That means whatever the legend is there, it will be come outside the plot. TM text, that means text I have added. There is a state name. Each and every polygon having state name. I am attaching with this. The TM dot underscore compass, that means there is a north arrow. I'm selecting the fourth star. There is a fourth direction will be representing, and position will be controlled by this position. There is a C. There is a position. There is a left and the top. So these are the outside. It is generated. There is a legend is comes outside. Okay, the scale bar, this is the scale bar. You can see this is the scale bar in the below, and 0 to 200, and with the interval of 200 kilometer. Then this is the bubbles I have based on DAP. And you can see there is a size of the bubble. It is denoting the how much the DAP consumption in each every state. So this is all about the vector data visualization. So now coming to the raster data visualization. Raster data, you have to have the few libraries. Just install it. There is a Terra, raster, SF, and the color viewers. Color ramps, that means there is a different sets of the color. Now I am setting the working directory as I have the data set in a different libraries. That is a raster data. So just I am setting the directory, and then I am listing all the files from the path. Path means whatever where the data is located, and I am looking for some pattern, that uniform pattern that I have. So these functions are used to the looking for the dot tif, this pattern, whichever the uh, files having, it will select only this. And before that, there is a star marks that may vary. That means that all the value, all the files, there is a variation will be there. That will be taken care by the star marks, but in the end, there is a should be a similar extension, that is a dot tf. Select that only value. There is a so this is the criteria. So just listing their values, then I am Rust function is coming from the Terra package. Just stack that all the value, all the raster are in a stack. There is a common platform, you can say. So just the stacking it. That is a then I am changing the name as original names are there. So this function, this line is taking care about the no alteration of the names. Whatever the original names are there, so this name will be remain same. Then you can plot the stack. Stack means there is all the raster data that having. You can plot it. So this is the automatically it will plot based on that. There is a scale that is showing the different color and what is representing. different color in that right side for all that particular all that the raster data. Okay, so next you can calculate the global mean for each and every raster. You can calculate the minimum value, then maximum value. So for that you have to call that function the global. Then you have to pass the stack. That means whatever the raster stack is there, then you can call the minimum, otherwise maximum, and na.rm. That means all the nan value. So we have to remove that. So narm true. That means so this is the plotting of the rasters. Okay, it takes taking time. Okay, okay, it's done. So you can take check the minimum value. You just see it is all the minimum value for the each and every raster can be shown here. You can say the maximum value, and others are also the functions are there. You can check it and just copy it and just give a exclamation mark and hit the enter. It will automatically shows what are the functions are available. Okay, so just explore it. Now I am similar fashion. I am reading that the save file that are available for the Pusha UTM. Similar fashion I have used before that vector data representation. Now to represent the stack that is a raster data, you can use this tm.sap save. Within that bracket, you have to pass the stack. Then tm raster style is count palette. Palette means that is a, whatever the color you are looking for. Then title you can add. Then shape that means whatever the raster shape that is a shape file that I have already stored in a states function. Then tm border you can change. Then you can add some arguments to control their opacity. Then facet means already known that there is a vertical grids that you can use. That is the I want to show that n row is equal to 3. That means 3 rows will be there. Then layout it there is a plenty of arguments are there. You can just explore it. There is a panel dot labs. There is a name stack. That means names will be there in the panel. Then formalities serif. That means there is a font will be in serif. Font space will be 2. So this is that. And then tm compass. That means there similarly there is a compass. There is a north arrow. That is position will be controlled by this, and there is a scale bar. So they are spacing. So just you can see there is a states not found. Then we'll just run it. Error in field. Some error it is coming. Okay. Well, don't go into. Okay, and just there's some error is coming. Okay, just and then you can also use that similar manner. You can here this is the continuous data like that. So this scale bar is representing the continuation. That means there is a no overlapping are there, but you can discrete map is also you can having that. Then you have to use the style is equal to quantile. That means whatever the values are there, it will be break into the 4 parts. Okay, fine. Then in the 4 levels that we can use the dry, moderately dry, and moderately wet, and the wet. So this is you can see that raster data. I think you have fully got this raster data. This ultimately this like file will be generated. So just see it. So this is the grid that is quantile. That means 4 parts we have splitted the data set into the 4 parts. That is a dry, moderately wet, and wet. So these color is representing this. So ultimately the that will generate this type of that plot. So some this is happening some errors. So that will be that will take care. Okay. Now you can also use the single plot. That is here the raster stack I have used. There is a multiple plots, multiple raster data that you can use the single data. So just give the path and their file name with extension and store in a variable name and just plot it. Okay. So it will give you a single raster data we can plot. So just wait. This is the single data or single raster stack. Raster data can be plotted. So that's all from my side.
Thank you so much. And with that, we have come to a formal end of all the technical sessions lined up for today. We do have some time to take questions from our participants. So, any questions that you would like to ask? Any thought, comment, anything?
Hello, ma'am.
Yeah,
Am I
Sangeeta,
audible?
please go ahead.
Yes. Sir, actually, since I'm very new to this field, I think this is a very basic question. If you don't mind, shall I ask it? That from where are we, like this shape files and raster data, like we have to download initially from some website and then use it? And
Well, you can
if
Google
any
it.
from the website?
You can
Yes.
Google it. The save file, it is already available for India. There is a different states or the countries. It is available. In the subsequent session, Dr. Pooja ma'am, I think will discuss about how to download the save file. And the raster data, that is all the satellite data. You can say there is a Landsat and all these.
Query from your end.
Okay. So you just crop it or mask it for your locations, and then you
Yeah,
can
please.
use. Okay, fine.
Okay, sir. Sir, these data are available freely? Like,
Yeah, different satellites are freely available. There is a Landsat, Sentinel. These are all the open source data. You can use it.
okay, thank you, sir. Thank you.
Thank you.
Yeah, I think Dr. Trideep has already shared. Dr. Trideep has already shared the data as well as the codes in the folder. But if it is not, then we will be sharing. No worries in that. Means you will get everything. Actually, basically, as you have seen that he has probably covered a 2 days lecture, something like that, in a very short span of time. But this is what our intention is, to give you at the maximum possible way what are the options which are available, because the codes are all, you need to go it again and again, then only you will understand what it is doing. But these codes are all available. He will be sharing, and as well as once you are googling, you will get lots of codes which are available. So you can just simply take that, run your R depending on what analysis you'll be doing. So it is only a matter of time that you will learn how to use these things. But what is important is that there is a huge scope of your data visualization by using R. There are a lot many packages which are available, which you can use it both in a vector and a raster format, both in a general graphing like say bar plots or any other plots, or spatial analysis like mapping. So next tomorrow you will be getting into this subject, that is the spatial analysis, how it is being done, how to generate the maps. So this is one very important part of the visualization, because R is known for visualization, R is known for statistical computing. So both of the things we have covered as much as we can do it during this short period. And I really, if they had, I don't know, Jinat, if there is not many questions, then we can
I don't
conclude.
think
Or
we
if
have questions. Nabil, would you
if
like to
we have,
say
acha,
something?
okay, Nabil, please go ahead.
We have registered your message in the chat also.
Thank you, Professor Gosh.
Yeah.
Just a question. Is R a software mostly used just for pixel computation, or also we can use, for example, machine learning, deep
Yeah,
learning?
you can use. There is a specific packages are there that like carrot package. You can use, explore that package, and you'll get some machine learning tools. Okay.
Okay, so we will explore these packages in the next few days.
Probably machine
Okay,
learning that will be covered.
okay, thanks. For land use, for example, for land use classification.
So this is the technique. We can say there is your objective that has to be your that you want to do some classification. So there is a technique will be there. So basically there is a machine learning tools are available in Carrot. Based on your objective, you can use it.
Okay, thank you.
So
Yeah, Nabil, we will not be covering into details of all the machine learning. It is only just to give you an idea of the usability of the software. We'll be covering the QGIS for a specific GIS analysis, and also we'll be covering the Sentinel data analysis using the Snap software. So there, these things also will be covered, but not in a sense that you will understand you will understand that how to go for this classification. Okay, but at least you will have an exposure to how to use those tools or what is called codes for your analysis. Okay.